December 6, 2007. Approximately 6:15 in the morning. Downtown Jacksonville, Florida at 500 East Bay Street. A 5-level, cast-in-place post-tensioned concrete parking garage under construction, known as Berkman Plaza II, partially collapses. At the moment of failure, construction crews are pouring fresh concrete for the 6th level. One construction worker is killed. 21 others are injured. This is not a structure that had stood for decades and quietly deteriorated. This is a structure that failed while it was still being built, during a routine, planned concrete pour that construction crews had scheduled as part of the normal sequence of erecting the building. The collapse happened in the early morning hours, while workers were on the structure, actively engaged in placing the load that would ultimately overwhelm it. In the aftermath, the event became the subject of a formal investigation by the Occupational Safety and Health Administration. That investigation was carried out and documented in a report authored by Mohammed Ayub, PE, and Dinesh Shah, PE. Their work would eventually trace the collapse not to a single dramatic event, not to a storm or an impact or a fire, but to decisions made long before the concrete truck ever arrived on site. This is the story of a structure that was, according to investigators, never capable of carrying the loads it was designed to carry in the first place, and of a construction process that proceeded, level after level, without the calculations that should have confirmed that basic fact. Over the course of this account, we will walk through what OSHA found in the design itself, what was missing from the site during construction, and what a subsequent arbitration panel concluded about legal responsibility for what happened that morning in December 2007. The physical event itself unfolded during a concrete pour. Construction crews were casting the 6th level of the 5-level garage structure, adding the weight of wet, uncured concrete on top of the levels that had already been built beneath it. Fresh concrete is heavy, and until it cures, it does not carry its own weight. It relies entirely on the formwork and the shoring system beneath it, and on the strength of the levels below, to carry that load down through the structure until the concrete gains enough strength to support itself. According to OSHA's investigation, at the time the 6th level was being cast, there were no reshores in place below the 3rd level of the structure, with the exception of a few reshores positioned under the perimeter beams. Reshoring is temporary support. Vertical props installed under a concrete slab or beam after the original formwork has been removed, intended to carry construction loads while the concrete below continues to gain strength, and while additional levels are built on top. Without adequate reshoring beneath the 3rd level, the lower portion of the structure lacked the temporary support needed to carry the load being imposed by the wet concrete being poured on the level above. This was not a failure of the concrete mix, and it was not a failure of a single beam breaking under a freak load. It was a structural system that level by level was not being adequately braced from below as new weight was added from above. The sequence matters here. A cast-in-place post-tensioned garage rises through a repeating cycle. Pour a level, let it cure, strip some forms, add shoring or reshoring as needed, and move up to pour the next level. Each step in that cycle depends on the step before it having been executed correctly. When the 6th level pour began on the morning of December 6, 2007, the structure beneath it was not carrying the load the way it needed to. The absence of reshores below the 3rd level meant that the lower floors were not positioned to help distribute or resist the additional weight coming from above. The result was a partial collapse that took place in real time, with workers present, while concrete was actively being placed. The missing reshores explain how the load traveled through the structure at the moment of collapse, but OSHA's investigation went further, into why the structure was vulnerable to that load at all. The investigation, authored by Mohammed Ayub and Dinesh Shah, found that the structural engineer of record had designed columns and beams that could not support the code-prescribed loads. In other words, this was not simply a construction sequencing problem layered on top of an adequate design. The design itself, as reviewed by OSHA, did not meet the load-carrying requirements set out in the applicable building code. Columns and beams are the load path of a structure. They are what carries weight from the slab down to the foundation. If those elements are undersized or underdesigned relative to code-prescribed loads, then no amount of correct shoring sequencing can fully compensate, because the permanent structure itself is not built to the standard the code requires. This raises the obvious question: how would anyone know whether a design meets code-prescribed loads? The answer is engineering calculations, documented computations that show, mathematically, that a given column or beam can carry the loads it will be subjected to. This is standard practice, and it is the mechanism by which a structural engineer of record demonstrates that a design is sound before it is built. When OSHA requested the engineering computations that would justify the design of Berkman Plaza II, the structural engineer of record could not produce any calculations justifying the design. This was not a one-time request. According to the investigation, the engineer was given multiple opportunities to produce those calculations and did not produce them. From a cost and schedule perspective, this detail is the center of the entire failure chain. A construction project moves forward on the assumption that the design has been verified before the first form is built and before the first truck of concrete arrives. Calculations are what stand behind that assumption. On this project, according to OSHA's findings, that verification did not exist in documented form, even after the fact, even when specifically asked for by federal investigators. The pours proceeded level by level, the schedule advanced, and the sequence of work continued upward, without the underlying engineering record that should have confirmed the structure could carry the loads the code required at every one of those levels. The consequence of this gap between design and verification was not abstract. It was a 5-level structure that, on the morning of December 6, 2007, could not carry the load of its own 6th-level pour. 22 construction workers were on or around that structure when it partially collapsed. One of them was killed, and 21 others were injured. These were people performing an ordinary task in the construction of a parking garage, placing concrete on a level that had been scheduled, sequenced, and approved to be poured that day. They had no way of knowing, from where they stood, that the structural engineer of record could not produce calculations justifying the design of the columns and beams beneath their feet, or that OSHA would later find those elements incapable of supporting code-prescribed loads. They had no way of knowing, from where they stood, that reshores were absent below the 3rd level of the structure. They were standing several stories above. The workers on site were relying on a chain of professional and institutional assurances that is supposed to stand behind every construction project. That the design has been engineered to code, that the calculations exist and have been checked, and that the temporary supports required at each stage of construction have been installed according to that design. On December 6, 2007, that chain did not hold. The absence of reshoring below the 3rd level was a condition of the physical site, something that could, in principle, have been seen and corrected before the pour began. The absence of engineering calculations was a condition of the paperwork, of the design record, something that would not have been visible to anyone on site that morning, because it was a gap that existed in an office, not on the structure itself. Both gaps existed at the same time, on the same project, and both are named specifically in OSHA's investigative findings. The result was that on an ordinary work morning, during a scheduled and unremarkable construction task, pouring concrete for the next level of a parking garage, the structure gave way, injuring 21 people and killing 1. There is no indication in the investigative record that the workers involved had any role in, or knowledge of, the design deficiencies or the missing shoring. They were carrying out the work as directed, on a structure whose adequacy had not been demonstrated through documented calculations, and whose lower levels had not been shored as the construction sequence required. In the months that followed the investigation, the question of who bore legal responsibility for the collapse moved into a formal dispute resolution process. A 3-member arbitration panel reviewed the matter and ruled that the collapse was the direct result of design errors, for which the responsible parties were held legally liable. That ruling aligns with what OSHA's investigation had already documented: a structural design that could not support code-prescribed loads, and a structural engineer of record who, given multiple opportunities, could not produce the calculations that would have shown otherwise. Read together, the OSHA findings and the arbitration ruling describe a failure that did not originate on the morning of December 6, 2007, but was built into the project from the point at which the design was finalized without a documented, calculation-based demonstration that it could carry its required loads. The construction sequence, pouring level after level, moving the schedule forward, adding reshoring in some areas but not consistently through the lower floors, proceeded on top of that unverified design. When the sixth-level pour added its load to a structure whose columns and beams were, according to OSHA, already inadequate for code-prescribed loads, and whose lower levels lacked sufficient temporary support, the combination produced a partial collapse. 1 worker died. 21 others were injured. A 3-member arbitration panel later assigned legal liability for the collapse to the design errors identified in the investigation. What this case shows, drawn only from what investigators and arbitrators documented, is the distance that can exist between a design being approved for construction and a design being actually verified to meet code. Calculations are the record that is supposed to close that distance before a single form is built or a single truck of concrete is poured. On this project, according to OSHA, that record could not be produced, even when investigators asked for it directly and repeatedly. The construction schedule did not wait for that gap to be resolved. The pours continued, level by level, until the 6th level revealed what the paperwork had never confirmed. Berkman Plaza II stands, in the documented record of this investigation and arbitration, as a case where the missing piece was not a mysterious flaw in the concrete or an unforeseeable load, but a set of engineering calculations that were never produced, and a shoring plan that did not reach the lower levels of the structure it was meant to protect.